Welcome, my name is Bryant. This is my Uillean pipe reed slip calculator project in FreeCAD. FreeCAD is a free and open source CAD program, and the version I'm using here is 0.21.0, and you can download this. It's free for all platforms. It's cross-platform. I'm not going to include installation instructions here, but their website, you can go there, find the downloads. They have excellent support as well, even though they are an open source community of volunteers. And this is just a great program. I've really enjoyed learning it and using it. And it can help with understanding reed geometry. So once you open this file by going to File, Open, and finding it on your file system wherever you downloaded it, you can see in the object tree here, we have a folder that has a series of sketches in it. And then we have an additional sketch to explain something I'll get to later. And each one of these is a geometric scenario describing slip geometry that has certain parameters constrained and certain parameters free so that you can calculate certain things based on other things. So the first thing you might want to do is calculate the quantities dip and centerline, and I'll show you what those are, from a given cane outer diameter, cylinder outer diameter, and slip width. So if we go into that by double clicking it and navigate to the origin, we have a slip. This is looking down on the end of a slip. And unless you're making some really funny looking slips, it might be from the side, but yeah, this is looking down into the aperture of the reed, in other words. So here we have there are four parameters that completely define a slip. They are the width, that's this, slip width, the edge thickness, so at the side there's a bit, we don't take it all the way to a razor edge most of the time. Most people don't. You could try it, but in real scenarios there will be an edge thickness. 0.25 millimeters is a common value for that. That's 2 sheets of paper about, nice and thin. And then we have the outer diameter of the sanding cylinder that creates the negative space here in the bottom of the slip, so that the slip is solid material here in the green. And then we have the outer diameter of the cane. And the fact that the sanding cylinder is larger in diameter than the cane gives us the half moon shape, wider in the center than on the sides. So in FreeCAD, in sketches, we can create these parameters called constraints. The red ones are examples that control the geometry that we see. So we're saying that this diameter here of the sanding cylinder is 70 millimeters. The blue ones are reference constraints, and they just report the value of what the dimension that they are defined along. They report what it ends up being. So when we want to calculate, when we want to enter something, we use a normal constraint, and when we want to calculate or see what something is, we use a reference constraint, because we don't know what it'll be, and if we tried to constrain it as well to a certain value, we would come up with an inconsistent geometry. So here we've entered a slip width of 12.5. It's common for D concert pitch wide bore reeds. 0.25 millimeter edge thickness, a 70 millimeter sanding cylinder, and 25 millimeter slip of cane. It's important to measure, if you're really getting into this, each slip's diameter with a drafting circle template, because the diameter of the different slips coming off of one tube, they can differ by up to 5 millimeters or more, depending on how eccentric it is. So what this is telling us is that this combination of parameters has created a dip of 0.56 millimeters. These are all in millimeters, these dimensions. A center line of 1.36, and for reference, the stature, which is the sum of the dip and center line, here is 1.92. So you can write those things down. You could take note. You could see if you like a certain dip, if you like to work with a center line, there are various opinions on which to use or if these things even matter. I'll leave that to you. So there you have it, calculating dip and centerline and stature from the 4 determining parameters of a slip. Okay, so the next thing you might want to do is to calculate so if you have a dip and a centerline and a width of a slip in mind, you might want to calculate the cylinder outer diameter and cane outer diameter required to create those parameters. It might happen. You might want to do that. So here, now we've reversed things. So in red, the actual constraints are the dip, the centerline, the width is still an actual constraint, and then the edge thickness is still a constraint. And the reference, the ones that we're calculating are the outer diameter of the cylinder, the outer diameter of the cane, and then, well, we have the stature as well. So if we enter the same thing that we entered, the same results that we got from the last calculation, I've written those down and I'll enter them again. 0.56 for the dip, 1.36 for the center line. What we expect and what we get is that we have a 70 millimeter sanding cylinder diameter, and the difference between this value and 70 is due to the fact that I didn't carry all the decimal points, so it's a rounding error. And then the cane is 25, like we had initially to generate this dip and stature. So, you know, if you wanted to adjust, see what it looks like, oops, not that one anymore, to adjust, say you wanted a larger dip, maybe go to something pretty large, like 0.7, you can see everything changes. So that just went up there. You know, if we wanted it to take the place of the center line, we'd need to bring that down by 0.2. So there. So that's effectively, you can enter whatever you want here. You could try entering just to have fun here, you could try entering a much narrower slip and watch it change. So here you can calculate a cylinder diameter and a cane outer diameter that would be required to create your situation here with your dip, width, and center line. Okay, so there's a concept that's introduced or mentioned in Dave Hegarty's reed making manual that I call the Froment Rule of Thirds. And what this is it's a statement about the relationship of the aperture of the reed and the full width of the head of the reed in this dimension. You can also say it's a relationship between the dip and the center line. So what it is, so here we have what the aperture of the reed. So that is the distance in the open center of the reed between the two surfaces. That's called the aperture. And then the full total width of the head, I've called it total depth here, is just the extreme surfaces of each blade in the same direction. So the Froment Rule of Thirds says that this one, the aperture should be is 1/3 of the total depth, and Froment supposedly noticed good results from that. And it's not too much aperture, it's not too little. Again, there could be varying experiences and opinions on that. So what we've done here is just illustrate that, and so you can see if I were to drag the outer surface wider, the aperture stays such that it's 1/3. So you can have a variety of different outer diameters of cane, sanding cylinder diameters, and then of course slip widths. If we go down again, it doesn't matter. What we're doing is constraining it to always be 1/3 aperture of the total width. And this also does have an edge thickness, so it's an accurate situation. So that's the Froment Rule of Thirds. And now that we have that in mind, we can figure out if we have a cylinder, let's say we're making a reed and we have a sanding cylinder with an outer diameter, and we want to satisfy the Froment Rule of Thirds, and we have a slip width in mind. Well, we can calculate the cane outer diameter required to create that situation and the resulting dip and center line to create a reed that satisfies the Froment Rule of Thirds. So in this sketch, we enter the width, we'll keep it at 12.5, 0.25, and we'll enter a sanding cylinder diameter of this, in this case, of, what do we have here? 80. Let's just change it a little bit. Let's change it to 75. Okay, so you can see everything adjusted. The dip here is 0.52. The center line is 1.049. So now you notice that is the center line is twice the dip here. So that is because when you calculate, when you derive the equation, the relationship between dip and center line for the Froment Rule of Thirds, it ends up that the dip is half the center line. So that's the situation we have there. And yeah, so this can give you an idea of, you know, if we enter a different, something quite wide, 100, we end up with a dip of 0.39 and a center line of 0.78. Again, dip is half of the center line. So we've just found out, and then what we were originally trying to get here is what diameter of cane was required to satisfy that situation. And the answer here is 43 for that massive sanding cylinder I put in. But if we put in something a little more reasonable, 60 millimeters, we need 24.37 millimeter outer diameter cane. And then again, we can read our dip and center line, but the main point was to get the cane outer diameter. So now we can flip things and say that if we have a cane outer diameter in mind, what sanding cylinder outer diameter would we need to satisfy the Froment Rule of Thirds, and what dip and center line would result from that? So here we enter our cane outer diameter. So I have it set for, you know, narrow bore flat cane, but let's set it back to, you know, 26, something you might receive on concert pitch diameter cane, and everything's, and we have a 10 millimeter reed. Let's put that back. Let's put it to 13, say, 0.25 edge thickness. So this is telling us that if you want this situation with 26 millimeter cane, 13 millimeter slip, and you want it to satisfy the Froment Rule of Thirds, use a 69.3 millimeter sanding cylinder. So that's what you can achieve with this, and you can read off the dip and center line that you would get. Okay, finally, this one's a bit more obscure, but if you had a dip, a cane outer diameter, and a sanding cylinder outer diameter in mind, and you wanted to calculate what width of slip would be consistent with that situation, you could do that. So if we enter, say, let's enter 25 and for the cane outer diameter. Let's enter something a little more reasonable, 70 millimeters for the sanding cylinder diameter. So this is not satisfying the Froment Rule of Thirds anymore. We've taken that away. And let's say we just know what dip we want. Let's say we know we want it to be 0.55. This is telling us that if you want the situation, your slip needs to be 12.4 millimeters wide. And usually people can control the slip width more often than not, and iterate things that way, but this could be potentially useful. It's also just interesting. So that is the full suite of things right now. I hope you found this interesting. I will, this video will be linked to in the Git repository that houses this FreeCAD file. And thank you everyone for your time. I hope you've enjoyed it. Have a good one.